That's our little safety issue. Just a quick Lean Division ad. You know, as an organization, we're dedicated to advancing the concepts of Lean and expanding the knowledge about Lean. So we're always looking for help. So if you are interested in learning more about Lean and getting very involved in helping to spread the word, we'd be more than happy to have you as a volunteer. You can contact any of us either directly while we're here today. Today's the fourth and last day, but we can you give us a call. We're all on the website. We'd love to have you participate in any way that you would like to. So, with all of that, I'd like to introduce Maria Carolina Diaz, who is going to be our speaker this morning. She's going to be talking about the Children's Hospital Emergency Dispatch Allocation System. Maria is an industrial engineer. She's got a bachelor's in industrial engineering and a master's from Florida International University. She's also a black belt, and she has worked with General Electric, Boeing, and Office Depot during her career. She's held several industrial engineering positions where she's had the opportunity to study mathematical models and improve productivity in a lot of product lines. She has significant credentials. She's a member of Tau Beta Pi Engineering Society and Phi Theta Kappa Honor Society. So she has very, very strong technical credentials, and I'd like you to all, if you would, welcome her, and I'm waiting to enjoy this presentation. I think the presentation is going to be about 20 to 25 minutes long, and then we'll take any kind of questions, answer, discussion after that. Thanks a lot, Maria.
Thank you. Good morning, everybody.
Good morning.
So I would like to start by asking you, how many of you would like to take your kid to a hospital and wait for a long time before you get transport service to transfer them to another hospital where they can get better care? You want your kid to wait for a long time and perhaps get more bad than he already is? No. Anybody? No, right? So today we're going to talk about the process that we follow to understand this problem that was happening at the hospital. A little bit about the problem is that they were losing some of the transport requests because they had problems in their system. After we understand what the problem is, then we're going to talk about what were some of the causes leading to this problem. And then after the root cause, now we're going to go through what were the solutions and what's the plan for the future to sustain that improvement that was achieved by the project. So a little bit of the problem background. When I first started this project, the hospital emergency director said, we are minus $3 million in this program annually. We are losing a lot of money with this program, and a lot of times what happens is that we cannot take the calls. He didn't give me any specific percentage information or how bad the situation was, besides the $3 million lost every year. So we started collecting some data. And when we collected some data, we realized that they were losing about 12% of those transport opportunities. So when we socialized this number with him, he said, no, extremely unacceptable. So we need to improve this process like right now. The goal for this project will be to take this 12% to a 5%. So pretty much the project started when somebody else calls the hospital to get the transport service, either an urgent care center of the ones they already have, or some other hospital. And it ends when the ambulance or the helicopter is ready to handle another transport. So a little bit about the system so you understand what's going on. referring facility calls the hospital asking for service, and that phase goes until the doctor says that they are accepting that patient, that the children is ready to get into the hospital. Then when that happens, it's when the response starts. That's when the team starts getting ready and the ambulance starts getting ready to leave the hospital and go look for them. Then after that, that's when the transit phase starts. It's the time that they take to move from where they are stationed to the hospital or the urgent care facility where they're gonna pick up the kid. Then we have the service time, which is from the time that we pick up the kid until we deliver the kid to the hospital's facility. And then after that is when they do the clearing, which is until they have the ambulance ready or the helicopter ready for the next transport. So one thing that is important to mention here is that it starts by somebody else calling the children's hospital, and then it cannot start unless they have a medical crew ready to handle this patient, and also they need the ambulance or the helicopter, as well as the correct equipment. If they don't have this available, it's impossible that they start the process. And also the universal transfer form, which is where they write down all the information of the patient. And then it is important also to note that for this to be regarded as a good quality service, they have to deliver the patient in a stable condition to the right location at the right time. So when we started this project, they had 4 ambulances, 4 ground ambulances, as well as 2 helicopters that they were using to provide service, and also 3 critical care teams and 2 advanced life support teams. And then they had some backup. From the graph, you can see that they were averaging about 12% missed transports per month, or 88% service per month. So we wanted to figure out when was it that they were losing most of the transports, to isolate where the problem was happening. And we did this graph understanding how many transports they were receiving per hour on an average. We realized that 37% of their volume mostly were between the hours of 5 and 11. And that's when they had most of their teams scheduled. However, this wasn't still enough, because this was also the time where they were losing the most transports. So the next logical question to ask was, why are we missing the transports? Why is this happening? And we looked at a series of calls and their corresponding reasons, and this is what we got. We got that most of the times they were losing transports because missions were in progress. That means the teams were already busy picking up other kids. Also, the second reason we found is that they lost transports to competitors. Perhaps the competitors could offer better service than they could, so they lost transport because of that. And then last but not least, the most important reasons is they lost transport because of maintenance, either scheduled or unscheduled maintenance. So we really wanted to understand, where should we focus? There is this big process. Where in this big process are we having the longest cycle time? To understand where should we start looking at this. So we divided all the ground transports as well as the air transports. For the ground transports, for both the ground and air transports, the highest time or the high cycle time was the service time. But that's a little bit more complicated to streamline, so we decided to leave it on the side to begin with. So for the ground transports, we decided to focus on the transit time and the clearing time. Because those were the longest cycle times. And then for the air, we decided to focus on the clearing time and the response time. So now that we were ready to start the analysis, mainly what we did during the analysis phase was that we conducted a 5 why exercise. So we started asking, why are we missing calls because of mission in progress? Well, the answer might be because they are already busy finishing another transport, right? So why are they busy doing another transport? Well, because we're getting too many calls. And we kept asking why 5 times until we got to a reasonable root cause that we cannot really answer any more questions after that, any more whys after that. So we did the same exercise for the transit time, asking why 5 times, the same with the clearing time, and so on. So when we analyzed when we did the 5 why exercise for the missed transports, we found that there was no team available to respond. From this graph, we can see that almost 30% of the transports we are missing, it's between the hours of 5 and 11, as previously seen. Also, what has happened is that we have seen an increase in the volume, but the number of teams or the number of ambulances or the number of helicopters has remained constant. So we have a big problem right there. And then the teams that are on backup, they are allowed 45 minutes to get to the facility, to get ready for the transport, and to some of the facilities requesting service, this is definitely not acceptable. So we miss transports because of that. So why were the ground transit times very long? Well, what was happening is that 5 of the ambulances were assigned to be at the allocation, and only 1 ambulance was there in the south. And as you can see in the graph, most of the volume is coming from the south. So you're going to spend a lot of time driving through traffic, crazy Miami traffic. So that was definitely not an optimal location for these ambulances. And then for the clearing times for both ground and air, some of the problems that we identified as root causes was that they had to go to multiple locations to restock for the next transport. So all the equipment and supplies they needed for the next transport was not in a central location. And also, they didn't have clarity as what the clearing procedure should be. So some would go to the final destination, and then they will go smoke a cigarette, and after they smoke a cigarette, that's when they will call, oh, I'm clear. Some will go and immediately say, I'm clear. So you can see a lot of variability there. You don't really know what the real time is of what happened. Finally, for the response times of the air transports, we identified that the root cause is that we have some critical equipment, as mentioned there, that is used in ongoing transports, and also we have limited availability of them. So if we don't have those available because they are already used in another transport, even though the teams might be available, we cannot start the transport. And again, the increased call volume and the on-call team is a factor again. And then lastly, we saw an increase on the regional service that is a little bit bigger. And again, we did not adjust our fleet accordingly. So now that we have seen all the root causes contributing to this problem, now we're ready to start going through the solutions that were proposed for this problem. So in a nutshell, we developed a standardized clearing procedure. We changed the location of our ambulances, and as well with that, we developed a standard map from where to dispatch the ambulances for in a south, central, and north region. And then finally, we develop a dispatching process, a standard dispatching process. So to describe those solutions, specifically is the standardized clearing procedure. Basically, we gave them a specific time for them to notify when they were clear, so they do it in the same manner, and we reduce the variability that way. Also, we gave them a goal to which they were going to be held accountable for. And in this manner, we will reduce all those clearing times that were all around the place. So in the graph here and the map, we can see where are all the hospitals that were calling them the most, and where is the volume coming from. So as such, we developed a new ambulance location pattern. We said that 2 of them were going to be located in the north, 2 of them were going to be located in the center, and 2 of them will be located in the south. And we said that they will each have assigned hospitals. One of the things that we were told that happened once was that there was an ambulance here, and it got assigned to transport over here. And then there was an ambulance here, and it got assigned to a transport over here. So they were both going crisscross. So if now they have an assignment of where each of these transports is going to be dispatched from, we're going to reduce the amount of waste in traveling around the city, full of traffic. And then last, we developed a standardized dispatch procedure for the patients with the universal transfer form, one for the patients without a universal transfer form, one for the international calls, and then one for the non-emergent transports. And again, what are the benefits of all of this? We will reduce the variability present across all specialists assigning these calls to the medical crews. We will reduce the time to service the transport, and we will eliminate that crisscross, because now they will all have a assigned location from where to dispatch from, as mentioned before. So these other suggestions were suggestions that the team came up with. However, we were not able to implement them during the course of our project because it involved the collaboration of other departments. So, for example, we said that we want to increase the level of critical equipment, and again, they need a lot of approvals for that, so that might not be immediately ready to implement. And then we also said that we're gonna agree with the repair shops that priority has to be given to these ambulances once they get to that repair shop to reduce the downtime of these ambulances. So what happened when we implemented all of these solutions? Well, what happened is that we reduced the percentage of missed transports from 12% to 10%. But hey, that didn't meet our goal yet. Our goal was 5%. There was still a long way to go. So we had to start brainstorming for new solutions and new options to get to our goal. So we came up with 3 different options. The first one was to figure out what the times should be for this transport. We were not going to tell them where to reduce the time from, but we will tell them this is how long it should take if you want to have a 5% missed transport. The second option would be, let's add a team during the peak hours. And then the third option will be, let's add a new ambulance and a new team. So we started with 138 minutes per ground transport and 260 minutes of air transport. When we improved when we implemented the solutions I just explained, we got to an 87 ground transport time and 178 minutes air transport time, which would be the same if we add a new team or a new ambulance. For the reduced times, as explained, I wasn't going to tell them what each of the phases should take, but rather they have to take 77 minutes at most with each of their ground transports and 158 minutes with each of the air transports if they want to meet their 5% goal. So when we started again, we were at about 39 missed transports, or 12.61%, or 2.49 sigma level. That's what we started with. We improved the process. We got to a 20 missed transports, or 10% missed transports per month, or at 3 sigma level. Again, this was not acceptable, and that's when we went to the options. As you can see, all of the options give us a less than 5%, which means all of the options will meet the desired project objective. However, some of them were more riskier than others, and some of them required more initial investment than others, or had a different payback period, etc. So from this chart, we can see, for example, that the first option had roughly no investment to be made, but the last option, for example, you had to almost invest $1 million. And then the first option, after 5 years, you will have a payback of a little bit more than $2 million. But with the third one, after 5 years, you wouldn't still have recuperated your investment. So you can see from this chart, and also taking into consideration that they were already losing a lot of money, the other two were not very viable options. The best way was for them to work together with the other departments to reduce the times. Yes, it takes collaboration. Yes, it takes working together. But they don't have any other viable options at this time. So that was the option recommended. So for them to sustain this improvement, because if you don't leave anything in place for this to continue, what's the easiest thing to do? Oh, let's just go back to how we were doing things in the past. That's how people usually are. So we created a control plan for them so that they are aware of what's going on and what needs to happen to stay in control. So we said that we were going to monitor the equipment downtime on a monthly basis. We also said that we were going to monitor the number of missed transports and the phases of the dispatch, response, transit, and clearing. We said we were going to monitor all of those in a daily basis. Why? Well, because if something gets out of control, you want to be able to immediately see it and make changes and take appropriate actions. You don't want to wait a month to make necessary corrections. You have already lost a lot of money by then. So this is the scoreboard that we developed for them, and with this scoreboard, it basically reports all of those key performance indicator we have developed, and you can quickly see what's going on in your system, as well as the number of missed transports and the percentage of missed transports, and then the equipment downtime. So after we finished this project, basically the main benefits that they got out of this was that they reduced the time of the transit time from 30 minutes on an average to 20 minutes. They also reduced the percentage of missed transport from 12% to 5%. They reduced the number of missed transports from an average of 39 to an average of 15. And also, they got aware of the necessity of doing good data collection and improve those practices, because that's what they're going to make all of their conclusions from. So it's imperative that they have good data. So we can see, we have seen in this project how do you scope and define a problem in the Six Sigma methodology. Also, how do you start going about collecting data, and what kind of data you need to collect in order to get your head around the problem. And then also, one of the techniques for doing analysis of this problem, in this case again we use the 5 why techniques. Then we also went through the process of brainstorming solutions and implementing these solutions. And then last but not least, putting a control plan in place. So as we can see, the Six Sigma methodology can be used on a broad range of industries, and the healthcare industry is one of them. Thank you. Does anybody have any questions for me? Yes.
You told that you were not going to focus on the service time as such, although it was the biggest block in the Pareto chart. I did see, however, in your current and future state comparison that also the service time drastically improved, almost like 50% if I remember well. Right? So like for ground service from 57 to 29, how did that happen? Is that like, was there some other initiatives happening on the service time, or was it just because people were focusing on the problem and then suddenly
yes.
you get a sort of...
Like when these Six Sigma projects start, what happens is that people usually get aware of what they are doing. A lot of times they are just doing things by inertia and not really thinking about what's going on. So we started creating this awareness, and they started doing the improvements on their own. But we didn't focus on this very much. Anybody has any other question for me?
How did you establish your transit times? Different levels, the transit times, how did you establish kind of like the benchmark?
Oh, because we collected data for one whole month. And again, when we collected all that data, it was horrible to begin with, because they had very, very, very bad data collection practices. So we kind of have to go through each and every one of those data points that they gave us and sort through which ones are good and which ones are bad, and finally we were able to get an average and a benchmark to start with.
Did you benchmark against any other facility or industry?
No. We just got the data for this system, and for the reduced times, we used a simulation program. The simulation program will tell us again what this time should be, should we want to be at this number of missed transports. All right. Any other questions? Yes.
Just for my understanding, could you please tell me that how many researchers or persons are involved in this?
How many?
How many researchers are involved in this program? How many people?
How many nurses and doctors we had in the ambulance, or how many people were in the project?
In the project.
Oh, we had like 4 to 6 people.
Oh. Very wide variety.
Yeah, we had the communication specialist taking the call, and the other facilities call. We had some of the nurses going in the transport. We had the emergency department director or manager, I should say. The director was the project sponsor, and he didn't work together with us. But he was the project customer, of course. And then, last but not least, both a master black belt, which was providing the training for us, and then me and my classmates who were taking the black belt training. Any other questions? And thank you for your time.
Thank you. Now, before you go, we have some QR forms in the back of the room. Somebody may have picked them up already, but if you would fill those out and leave them with us from your evaluation of the presentation.